Yes, thank you very much. Thank you, Jesus Ese. The next speaker, it's my pleasure to announce from Zero2Infinity, the founder and CEO of Zero2Infinity. He has a close, lifelong relationship to space exploration. A round of applause for Jose Mariano López Urdiales.
Thank you. Hello, everybody. I'd like to take you on a trip to space for a few minutes. So imagine one day when the whole world is connected. No matter if you are on a plane, in the sea, in the forest, skiing, you're connected. Imagine a world in which we can understand the planet and we can monitor the planet. And when you go on Google Earth, you see your backyard real time. You're not seeing a picture from 6 months ago. And this is a world that is not a question of if, it's a question of when that's going to happen. And the only way to make that happen is by sending a lot of things to space. So we know this. But why is it not happening? Why is it taking so long? Because we've got cameras, we've got radios, we've got mobile phones, microelectronics can do incredible things. We are solving for that problem at Zero2Infinity. We're facilitating access to space for hundreds or possibly thousands of small satellites so that we can solve all these problems of connectivity, of understanding the weather, understanding the pollution, understanding human fluxes of people, all these things. So why is it difficult to send something to space? Well, traditionally, we've been sending stuff to space using missiles, okay? Like if it was the end of the world. In truth, we have satellites because it's a collateral damage or it's a byproduct of the fact that we've built large nuclear missiles. And right now there is a race to change things, to make it, to open up space, to democratize the space. And the big players in this race are here on the left. You probably recognize the ones that are into this SpaceX logo. This is Elon Musk's company. He also runs Tesla, and he used to found PayPal. The one with the feather, that's Jeff Bezos' company, who's the wealthiest man in the world. He runs Amazon as well. So some pretty smart people are building rockets, and they are trying to build them as big as possible, And our understanding is that maybe what you need is not to build something as big as possible, but just to do it differently. Maybe we have to step away from the missile paradigm and do something else. Launch more frequently, launch more reliably, make it easier to get to orbit. Have a service that is going up and down all the time. And the bigger the rocket, the less you're flying, because the amount that you're taking is constant. So we see that, yeah, they're very smart, they have a lot of capital, but they're going in that side of the spectrum. So there's a bunch of people on the right. They're building small rockets, as you can see, little, thin, tiny ones. These are adapted for masses around 100 kilograms. And in the world of today, with 100 kilograms, you can do a lot. And the ones on the right, the good thing, and we're here about talking about 3D printing, the good thing is you can 3D print the engines. And the engines are the most expensive part. So what we built is a rocket, that is the one with the arrow, that is called Blue Star and looks nothing like a normal rocket and takes full advantage of modern technology in terms of navigation from the drone world, 3D printing for the engines, carbon fiber for the tanks, etc. So this is how it looks with a person for comparison. There are 3 stages. 2 have the shape of a donut. Another one has the shape of a muffin. So this way, all the engines are firing at once. And you've got a lot of engines, but they are produced still in small numbers, so they are very suitable for 3D printing. And this actually that you have here is a prototype of an engine that has been 3D printed in Seville with the partners of Fadacatec. And as you can see, the fairing is very large. The satellite has a lot of volume. So this lets you fly solar panels, radar reflectors, antennas, the parts that provide the performance of the satellite. Performance of a satellite doesn't have to do so much with mass of satellite, but now it has to do with surface, because the effective function is the surface. And maybe the resolution of the pictures comes with the size of the mirror, the power available comes with the surface of solar panels, all these things. So we are moving away from this little tip of missile things to something much wider. And how it works, well, you launch from the sea, you use a balloon as a first stage. This dramatically simplifies the rocket. The balloon, you don't use the balloon to gain altitude per se. It's not a question of, oh, I'm 25 kilometers higher, I'm saving propellant. You do save some propellant, but the propellant is a tiny fraction of the cost. What you save is the number of engineers that you need to hire to get to orbit. That's really what kills you. You have to hire like 30 people to develop these turbo pumps that rockets usually have and are difficult to 3D print and are difficult to manufacture, and it's a very intractable problem, this turbo pump problem. And by going up there, instead of having these pumps, basically the vacuum of space, when you go very high, there is like vacuum, and the vacuum of space is sucking the propellants out of the engine, out of the tanks, so you don't need to pump it anymore. It's just self-pressurized. So this reduces by a factor of 10 the cost of development. So just a bunch of engineers can build a rocket engine that works very well in space, but that wouldn't even start at sea level. The hard part is the first part, traditionally, and the first part is done by balloons. Balloons are reliable, they exist, and we've been launching a lot of them. So let me show you a video of how we want this to be. So we can launch from the sea, so no need to invest in real estate. The Canary Islands are an ideal location for it. And your ship is going to move at the exact speed as the wind. And that way the balloon just inflates straight. You don't have side forces on the balloon. You take the rocket up to 25 kilometers, check that everything's fine, and then from there you ignite all engines at once and push ahead to orbit. So the rocket will be burning a mixture of liquid oxygen and liquefied natural gas. Both things are readily available, they're very well understood, and it's very easy to make components or to acquire components because there are large industries in the healthcare sector of liquid oxygen and in the traditional industry of natural gas. So nothing exotic. You can send a multitude of configurations of satellites. And the first stage separates very, very early, so it's very easy to land back. If you think of it, it's like a 6 engines donut. So it's like a multi-copter drone. So it's very easy to control and land back on either on a barge in the sea or on a launch site. So the company is funded by venture capital and business angels from Hong Kong, Spain, Germany, France. And we're working with several governments around the world who want to acquire this capability, who want to be able to be the master of their own destiny, want to put satellites on their own, and don't want to depend on the usual suspects to get to orbit. So that was a computer video, but this is a real video, okay? This was done in the Gulf of Cadiz. This is a prototype, scale 1. This is not the full-size vehicle, but we wanted to demonstrate certain things, test the avionics, test the procedure to launch the balloon from the ship, recover the payload, and you're gonna see the rocket fly away in 2, 1, go. So if that was done at sea level, it would have not gone that far at all. So now on the 3D printing side, we are not buying 3D printers, but the good thing is that the taxpayers of Europe are just funding lots of 3D printers in lots of research places, and they're very keen to use us as test subject and give us away their 3D printing systems. So this is printed on aluminum, this prototype, and this is the printing of precisely this one. Aluminum has a very high conductivity, thermal conductivity, and that's something that you want on a rocket because you have to get rid of the heat. And one of the big challenges of a rocket is not to melt. So basically you inject the fuel, the natural gas, you inject it here at the end of the rocket, and then it goes through some channels, and then it's picked up here. And this was usually done in a very cumbersome way, just soldering lots of little channels to each other, and it was very difficult, and it took several months, a very skilled soldering talent. Now this is all done with 3D printing, but what we're looking at is that we can even use two types of channels with the fuel, the liquid methane, the liquefied natural gas, but also channels with the oxidizer, with liquid oxygen, because you got the very cold liquid oxygen there, and instead of just injecting it in the engine, you can make it go through the chamber and cool it so that the chamber doesn't melt. And also, you also take that heat, which is from a thermodynamic standpoint is very useful. It helps you get the most juice of the chemical energy in the propellants. So this is being done in Spain. It's interesting because most of the papers on how to prepare the powder, the 3D printing process, the laser sintering, and so on, are European. Some are Spanish, a lot of them are German, and most of the knowledge comes from Europe. And in the last 5 years or so, there's been a lot of companies in the US, 3D printing engines, and talking about it, using European machines and using a European know-how. Whereas in Europe, I believe we're the first that we're doing this kind of thing as a company. And it's surprising that it's taking so long, because in some way we are putting a lot more effort on the fundamentals. Okay, it's great to understand the powder, it's great to understand the machines, but not so much on taking advantage of these industries, in my opinion. Whereas in the US, they are just on a roll, and also in China, they are just taking advantage of all the fundamental research that is being done here in Europe to get real products to the market. And there's a missing link here in Europe, in my opinion. So that's my contact. Feel free to shoot me an email if you want to send something up on a balloon or to orbit, or if you know some company that may be complementary to what we're doing. I'll be delighted to follow up. So this is what I wanted to say. I think I'm fine with time, and be happy to join on the panel in a few minutes. Thank you.